Hey guys, here is day 3 of our notes for Unit 10. So we've got a couple learning targets. First, I'll be able to use formulas for surface area and volume to solve for missing variables. Then we'll be using surface area and volume when one variable is in the terms of another. And lastly, we will be looking at composite solids. So that's going to be kind of like our composite polygons from our earlier unit. All right, so first of all, we want to look at how to solve for a variable with our formula. So I've got that the volume of a sphere is 36 pi. What is the radius? So from my formula sheet, I know that the formula for volume of a sphere is 4/3 pi r cubed. So now that I have my formula, I know that the volume is equal to 36 pi. So I can write that 36 pi equals, and then I'm just going to copy down my formula. So I need to find that radius because that's what I don't know. Well, the first thing I see is that I have a pi on each side, so I'm going to divide away that pi so that those cancel. Now I've got that 36 equals 4/3 times r cubed. Just like we did in our circles unit, we can divide by 4/3 or multiply by the reciprocal. So multiply by 3/4, just our opposite fraction. So those will cancel over here, and then 3/4 times 36 is going to give us 27 equals r cubed. And then our last step's kind of like square root, but since it's a cube here, we've got to cube root it. So cube root each side so that I get just r. And the cube root of 27 is r equals 3. So that means that my unknown variable was r, and that equals 3. So you kind of just have to work backwards here, start with what you have, and you're just solving for that variable. All right, I'm going to let you guys try this one now, so please pause your video and try this problem. After you've done that, slide your paper down, and we are going to try one of these mixed word problems. So we will be doing this one here. I've got a cylinder with a radius of 4 inches and a height 3 times the radius. What is the surface area? So if I look at my formula sheet, the surface area for a cylinder is surface area equals 2 pi r squared plus 2 pi r h. So I just copied that straight from my formula sheet. And then I have that my radius is 4. And if the radius is 4, the height is 3 times the radius. So my height equals 3 times this radius that I know. So 3 times 4 gives me 12. Now that I have that, I can just plug my radius and my height into my formula. So surface area equals 2 pi times 4 squared plus 2 pi times 4 times 12. All right, if I multiply these out, I'm going to leave it in terms of pi. So multiply everything but the pi. 2 times 4 squared gives me 32 pi, plus 2 times 4 times 12 gives me 96 pi. And then when I add these together, I get that my answer is 128 pi. And then if I multiply 128 times pi, my surface area not in terms of pi is 402.1 inches squared. So we've kind of seen this the past 2 days. It's just only giving you one variable and giving you more of a trick to find the second one. So it was 3 times the radius. So you need to read carefully and underline important parts. Go ahead and pause your video and try this problem maybe, or you can... All right, now that we have finished this problem, you don't have to pause your video. I'll let you do these later. I want you to flip it over so we can look at those composite solids I mentioned. So you want to slide your paper all the way down, and we're looking at these composite solids. All right, I'll be honest with you, this is one of my least favorite parts of this. These problems can get a little tricky, so I'm going to walk us through both of them. Using the diagram, what is the approximate volume of the solid below? So if I look at this solid here, I see that the top of it is a cone and the bottom is a sphere. But it's only part of the sphere. It's actually only half of the sphere. So that is going to be important later, so I'm going to fill that in here. All right, so first let's do the cone. So to solve these composite solids, I want you to split them in half and just look at one solid at a time. So I have a cone and a sphere. And like I said, let's do the cone first. So for the volume of the cone, from my formula sheet, the volume is 1/3 pi r squared times the height. My radius of the cone right here is 28. So radius equals 28. And then my height of the cone is 49. Now that I have those variables, I can just plug it in and solve. So volume is 1/3 pi times 28 squared times 49. And then if you just type that whole thing in your calculator, you find that the volume is 40,229.14. And like I said, if we look at the whole composite solid here, I've got my whole cone as part of it. So how much of the solid am I using? The whole cone, all of the cone. So then that means my final volume is exactly what I found here. So I can write in this blank, just copy down my volume. So I've got my volume for the cone. All right, now we're going to move on to the sphere, which we only had half the sphere, so that will be important now. My volume formula for a sphere is 4/3 pi r cubed. Got that straight from my formula sheet, and we already said our radius is 28. So even though the radius is of the cone, it's also the radius of the sphere. So they share that radius. All right, if I plug in my values, I get that volume equals 4/3 pi times 28 cubed. Which, if I type that in my calculator, I get 1,393.8. So this is the volume of an entire sphere with a radius of 28. But this sphere in my problem is only half of the sphere. So since I only have half of it, I need to cut the total volume in half. So to cut it in half, I need to divide it by 2. So my total volume divided by 2 gives me a final volume of 696.9. So this is half of the total sphere's volume, but since I only have half of a sphere here, that's what I need. So now that I have the volume of the cone and the volume of the sphere, if I just add those together, it gives me the volume of this entire composite solid. So adding those together, I get 40,925.9. So that rounds to 26.0 feet cubed. Oops, there you go. All right, one more problem we're going to do all together. So we're going to do this other composite problem here. You'll probably see, maybe one of these on your test, so I don't want you to stress a lot about them, but it's something good for you to try. So if we slide over here, this time I want to know the surface area of this container. So to find the surface area, again, I need to split this into two parts. So I see that I've got a cone again on the top. This time we have a cylinder on the bottom. But surface area, volume is talking about the whole inside of this over here, but surface area is this outside part. So if you look at the cone, if you're thinking of looking at this from the top down, this bottom part of the cone is touching the cylinder. They're stacked on top of each other. So this blue circle that I'm coloring here is smushed in the middle. So is it on the outside? Is it part of the surface area? No, it's not part of the surface area because it's not out on the surface. It's on the inside this time. So this is not part of the surface area. And since this is just a circle, I know that the area of a circle is pi r squared from my formula sheet. So pi r squared is how much that is, which is going to be important. Since it's not part of the surface area, we're going to have to take this away from everything. Alright, so now let's look at each solid. So I've got my cone and my cylinder. So the cone, the formula for that, for surface area of a cone, is 1/3 pi r squared times the height. But we don't want to include the bottom part of the cone since it's not on the outside. So I want to omit. Omit just means do not use this part of my formula. So if my variables are radius of 5 and a height of 4, I want to plug this into my formula. So the surface area equals 1/3 pi times 5 squared times 4. So that gives me, let's see, 33.3 pi. But like I said, I don't want to include this part, so I need to subtract pi r squared. So pi times 5 squared. So if I subtract that and type this in my calculator, I get a final surface area of 8.3 pi, or you might have gotten 26.2. So this is the surface area of this cone, but not including the bottom circle because that's not part of the composites outside. Alright, now same idea with this cylinder. My surface area is 2 pi r squared plus 2 pi r h. This time, again, I've got the top here that I don't want in the cylinder because it's not on the outside. So I want to omit pi r squared again. My variables are, the radius is 5, same thing, they share the radius, and the height of the cylinder is 10. So now if I plug into my formula, I get, let's see, looking up at my formula here, if I have 2 pi r squares and I don't want to use one of them, then 2 pi r squares take away 1 pi r squared, leaves me with just pi r squared plus 2 pi r h. So I plug that in, I get pi times 5 squared plus 2 pi 5 10. So if I type that all in my calculator, I end up with 392.7. And then just like we did, if I've got the surface area of each shape, not including this inside part, I just add them together, and my total surface area is 418.9 centimeters squared. Nice job, guys. Thank you for watching. Try the rest of the problems on this worksheet now.